Of course, Super Mario theme. What?
Are we gonna have time to do anything? Like last week's our last full week, and we have like 2 minutes left.
I'm aware of that.
Are we like gonna?
It'll be tight, but don't worry. We're almost done trig. We'll easily finish trig early next week, and the finance unit is basically, here's how you use your calculator. No, it's going to be accounting, pre-accounting. All right, so, ladies and gentlemen, last year, when most of you were introduced to trig, you were introduced to working trig with a right angle triangle. And that was it. Now, that right angle triangle might have moved around, but you did no trig with any angles bigger than 90 degrees. Now this year, this happened. And the angle became bigger than 90 degrees, but we were able to use the reference angle to still do trig, right? Well, now we are going to learn what to do with this triangle on this side. So you don't need to worry about the reference angle. Okay? All right. Now, right here you see a formula. Normally I don't give you the formula right away. Normally I make you build it, right? Like we did for yes, the quadratic formula. Thank you. And indeed, I did not want that to be there. But when I made this page, I forgot to take that out. So it's there. But of course, we are going to build it anyway. What these notes should have looked like was this. Draw a triangle. Now, label that triangle. Label the vertices A, B, and C. I am not labeling it because I want you to label it yourself because it does not matter. Now I'm going to do a fun thing. I'm going to label A, B, C, and I'm going to see how many of you erase what you have and change it to what I have. Where will the A go? Where will it go? A. Yes. How many people had their A up there? All right. So B, C. That's how I'm going to label mine. Oh, big winner, Matipus. Okay, but seriously, folks, it really doesn't matter, yeah? Okay. Now, can I do trig with this triangle as it's drawn right now? I could write down some letters on the side, couldn't I? What could I write right here? Little A. What could I write right here? Little B. What could I write right here? Little C. Now, of course, yours is going to be slightly different than mine if you put your big A, B, and C in a different spot, yes? All right. Now I'll ask again. Can I do trig yet? No, why not, James? I got no angles and no measurements, okay? All right. So even if I did have an angle, let's say I had this angle, 47, and let's say that was, don't write these down, 63. Could I do trig yet? Still not. Why? You don't have the lengths. Right. I don't have any of the sides. Yeah? Okay. What if I gave you, what did I have there? 47, 63. And what if I told you this side was 12? Could I do trig yet? Yeah. No. Why not? I got no right angle triangles. Okay. So everybody should be very comfortable with the fact that I need a right angle triangle to do trig, right? But of course, there are triangles that don't have right angles in them. Like this triangle right here, right? What are we allowed to do? We are allowed to make 90-degree triangles. How do I make a 90-degree triangle? I split it. Don't say down the middle. That's a big mistake. Because watch, if I do this, and I split it there, that's not the middle, is it? This side is...
That would be the middle anyway.
Right? No. But you have to understand, and there's a reason, trust me. What I'm getting at is, what Jacob is saying is he wants to draw this line right here. And that's okay to do. The mistake with what he said was he said the middle. Now he says he didn't mean the middle. That's fine. The reason I'm giving him a hard time is because if you get in your head that this cuts this triangle in half, what does that mean for this distance and this distance? They're the same. And they aren't necessarily going to be the same, are they? Everybody cool? So let's drop that word from our what we're talking about. Take middle out of there. All right? What we're going to do is we're going to draw this line. And this line is what is called an altitude. Anytime you go from one vertex of a triangle straight across to the opposite side and make a 90 degree, you have drawn an altitude. Now, the reason I've drawn it this way here is because when we hear the word altitude, we think of height, right? Okay. Now, is the orange line I'm about to draw an altitude? Yeah, even though it's not the height. Everybody cool? All right. So now, altitudes, textbooks always use the letter H for an altitude. Because altitude we automatically associate with height, yes? What's wrong with using altitude for H? Or H for altitude, I mean. Why would that be a bad idea, do you think? That's one reason, it's not always height. I don't like using it because we've already got H going, don't we? It's our hypotenuse, yes? So the three trig ratios are only used for right triangles. But we're going to talk about how to fix that problem now. So the altitude exists here, right? Do we have a measurement for it? So what do we give it in math when we don't have a measurement? We give it a variable. The textbook's going to use H. I hate that. So I like to use the letter that we never, ever use in math. I call it Q. Everybody okay with that? Now, let's look at this situation for a minute. Now, I have this triangle. Right? I have this triangle on the right too, but I'm just going to deal with this one. Because if something works in this right triangle, it will work over here, won't it? Just like sine works in every right triangle. Everybody cool? Okay. So talk to me about some of the stuff we know about this triangle right now.
It has 190 degrees.
It's got a 90 degrees, so now we can talk about trig, yeah? And SOHCAHTOA works with right triangles, yes? Now you're intelligent young people. We're using sine law right now, so let's just talk about sine, okay? Which of those three angles, A, B, or this guy here, is it worth discussing the sine of? It's either going to be A or B, right? Because the sine of 90 is what? Who remembers? 1. What's the point of dealing with that, yeah? And this 90-degree angle here isn't actually an angle in the triangle we're working with, is it? We made that angle, so we don't care about it. So we got to care about A and B. Agreed? All right. Which one do you wish to work with? Because it doesn't matter. We're going to work with B? Okay. What is the sine of B? Q over what? C. Everyone agree? Yeah. Okay. What then is the sine of A? No, not A, sorry. A we've cut in half. What is the sine of C? Q over B. Does everyone agree? Okay. What letter in this construction that we have built here is a letter that doesn't really matter to us? Q does not matter to us, does it? Because we made Q, right? So let's get rid of Q. How would we do that? Well, how would I make this something that I could get rid of Q? If I multiply by C, Q is going to be left by itself, isn't it? So I'm going to have sine B times C equals Q, yes? Everyone cool? And what would I do down here to get rid of? I'd have sine C times B would equal Q. Does everyone agree? Now, how can I get rid of Q? If that equals Q, and that equals Q, how can I get rid of Q?
We can change Q to one of them.
Right. Substitution, isn't it? So now, from here, we know that sine B times C equals sine C times B. Correct? Everyone follows this? Now, of course, the only thing wrong with this, because this is all we need to do. But there's a problem here, because math people don't like this, because it looks ugly. Right? Math people want, if there's a B there, they want it over here. They want the B's together. So how would I get rid of this B? I'd divide by B, which means I would have to do the same thing over here, yes? How would I get rid of this C? I'd divide by C, and what would I have to do over here? Now, what do you see here? Cancel, and what do you see here? And what is left? Sine B over B equals sine C over C. Now, you're intelligent young people. If two parts of a triangle work, doesn't that mean the third part has to too? So what's left? Sine A over A. Now this is the way I learned the sine law. At some point between 1990 and 4 or 5 years ago, the math people of the world decided that this is the way we should write the sine law. Does it matter? No, because either way we're going to be doing some algebra and finding the answer, yes? All right, let's do so. Number one, I want to know two lengths, yes? Well, before I can do that, what do I need? I need a triangle. Doesn't matter what it's going to look like. Why not? I've got the angles, I've got the numbers, right? So I only need that triangle for reference, yeah? So does it matter how it looks? No, so everybody draw a triangle. Doesn't matter how it looks. As long as it's triangle. Everybody good? Okay. What do we have to label it? ABC. How are we going to label it? You could do it the same way you did the first one. Could you mix it up? Sure you could. I'm going to do the same way I did the first one. A, B, C. Now, do I know any information about this triangle? I know angle A is 40. So where's that going? Up at the top, 40 degrees. Can everybody see this shade of blue? I like it. It works very well on my page. Does it look fine up there? Okay. Do we know anything else? Is? Angle C is 115. 65. Why is it 65, James? Angles of a triangle have to add up to 180, so that's 65. And what else do we know? Where's that? It'd be little c, 6. What's missing?
AC and BC.
Now, AC is what we would have called it in the 9th grade, right? What do we call it now? Lil b. And BC is what we would have called it in the 9th grade. What do we call it now? Lil a. And now we just do our work. Do we know any of these three pairs? Which one do I have? I have this one right here, don't I? So, fill in what you know. Sine, what is big C? 65. Over, what is little c? 6. Equals the sine of what? Sine of 75 over what? Little b. I'm going to change color there. I want to use two different colors for this. Sine of, 75 over little b. And sine of 40 over little a. Now, I have two variables, don't I? How do I solve this side? How do you solve everything that is fraction times a fraction? Cross multiply. So, what cross multiplies? Sine 40 and 6 or a and sine 65? Sine 40 and 6 because they're both known. So I get 6 sine 40. And what do I do with this other side? There's a shortcut, or I can do all the work. Who remembers the shortcut? You divide it. But let's say you don't. Jacob says we got to cross multiply. So that's going to equal sine 65 little a, yes? What do I have to do there to get little a alone? Divide both sides by sine 65. So I'm going to go ahead and erase that, and that's going to equal a. Everybody cool? We're not going to do it yet because I want you people now to tell me what this side is going to look like. Oh, I shouldn't have used green. What's going to happen over here? Easy peasy lemon squeezy. Now, how do you do that on your calculator? Well, let's see. Six sine 40. Now, my calculator puts a front bracket. So what do I have to put here? Another bracket. Divided by what? Sine 65. Now, my calculator, again, puts a bracket. I don't need to put the second bracket here, but I'm going to. Why? So I'm used to closing that bracket in case I have to close it at a later time. Everybody good? I'm going to close that bracket. And I'm going to get me an answer. 4.3. 1 decimal is fine. Everybody agree? Can all see behind me? You know that A is 4.3. Now you try for the green one. I don't want to hit equals yet. What do we got? 6.39, so 6.4, yeah? So let's come over here. B was 6.4, and A was 4.3. Have we done our work correctly? Let's check. What do we know about angles and sides? Angles add up to 180. Sides don't add up to anything because they can always change. Where is the biggest side? No, you're right. It is the hypotenuse. So that is the hypotenuse in a 90-degree triangle, yes? So that, let's say this is a 30. Let's say this is a 30, 60, 90, right? What was the hypotenuse in a 30, 60, 90? 2. What was this side? What was this side? Root 3. Now, what's the biggest angle? 90. What's it across from? Hypotenuse. What's the littlest side? Or littlest angle? What's it across from? The littlest side. What's the middle-sized angle? 60, and it's across from the middle-sized number, yes? Well, let's check if we did our work right. Is the biggest angle opposite the biggest side? Yeah. Is the littlest angle opposite the littlest side? Yeah. One more check to make. 75 and 65 are pretty darn close in angles, yes? So shouldn't their sides be pretty close in length? Are they? So we're good. Everybody cool? All right. Let's do number 2. What does this verb solve mean in triangle speak? Right. Means find all angles and sides. So how must we start every single trig question? We need a triangle. Boom, boom, boom. What should we label that triangle? D-E-F. D-E-F. Do we know anything about this triangle? What do we know? D is 35. And? 12. And? 7. How are we going to solve this? Well, same way we solved the last one. Do I have a pair? I do, but it's not A, B, and C, is it? Because I've changed the letters. Why have I changed the letters? Because I get so damn tired of hearing, I know how to do it when it's not A, B, C. What is the pair that we have here? 7 and 35, right? So, sine of 35 over 7 equals what? Sine of E over what? 12. Do we know how to solve that? Is it fraction equals fraction? We multiply the pair, we divide the spare. What's the pair that we have there? Right there. 12 sine 35. I wrote sim. Sine 35 over what? 7 equals sine E. Now, something weird's going to happen. I go to my calculator and I punch in what I see. Everybody do so. 12 sine 35 divided by 7. Well, that's not an angle. Of course it isn't. I got to shift this, don't I? I have two choices. I could do all the work, and then I could use my good friend, second sine, and then the answer, and I could get my answer of 80 degrees, yes? So E is 80 degrees. Or, and this will save you some time, I just need this right here at the beginning of this, don't I? Shift, sine, and then I just punch in what I had. 12 sine 35 divided by 7. Now that should give me the answer, shouldn't it? Everyone agrees? Enter. What the hell?
You put in just 5 instead of 35.
Ah. Shift, sine, 12, sine, good job, Ashton, 35, divided by 7. Right? Yeah. Enter. There we go. Do I care how you do it? Of course not. But you got to remember, if you get a sine E, that must mean at some point you have to shift sine. Okay? Now, does that give us the rest of the triangle? If this is 80, do we know what this is? What is it?
65.
Excuse me. 65. Right? So now I have sine 35 over 7 equals sine 65 over what? Little f. Now, when I do this work, am I going to end up with a sine by itself?
No.
So do I need to hit shift sine anywhere? No, because this is going to be 7 sine 65 divided by sine 35 equals f. No sine there, so no shift sine. I just do this as I see it. So let's punch that in and see what we get. Damn it, I did it again. $11.1, yeah? I don't need to do a review on rounding. 11.1. Now let's check. Are we happy? Is the biggest side across from the biggest angle? Is the littlest side across from the littlest angle? So we did okay. Is everybody good? Now remember, these are the easy ones. Something very weird can happen with the sine law. All right? And we're going to talk about that on Monday. There's no way I'm going to try and teach you the weird thing that happens with the sine law on the last day, on the last block of a week when it's snowing outside.
Your calculator will literally explode.
Okay? So, that's what I said. Easy stuff, little bit of work to get used to it, wrinkly stuff Monday, and then back to the work. So turn the page over, and I'm giving you the rest of the period to work. This is what you're not going to do today. You're not going to do 6. You're not going to do 8. You're not going to do 9. You are going to do 2 of the word problems on page 209. Do I care which ones? No. And that's where we're going to stop today. Hokey dokley? Hokey dokley.